So apart from the global and local scope, right, we discussed about three ways of using functions, right? Functions which take your required arguments. Okay, so let me do this, and also I'll tell you what does module mean. Okay, okay. So let's say I define two function here. I'm going to say def uh, um, function one, or I'll say my fun. Okay, my fun one. Okay, you take um, a comma b, right, and you perform. Okay, you perform here sum equal to a plus b and multiply equal to a into b. Okay, and um, then you have um, division. Let's say keep it simple: a minus a divided by b. Right now, what we'll do is result. I'm going to say define a result, and I'm going to say bracket s comma m comma d. This is like packing. Packing into what? If you want, you can print the type of result. Packing into what? What are we packing? What is the data type that will create? Come on. What is the data type that we are creating here in line number 6? What is the data type? Come on, guys.
Int.
Packing, unpacking, where did we discuss? You see the bracket here. What bracket is this? Where do we use this bracket? Tuple only,
Tuple.
right? Yes,
Tuple.
correct. So look at the bracket. Okay, if I had used curly bracket, it would have become dictionary. If I had, in this case, it would have become set because you don't have key value pair. Okay, if you had used square bracket, it would have become list, right? So square bracket.
List.
Yes. Okay. So look at the bracket. Okay. Okay. So, I want to return as tuple. So I'll say tuple, right? Or let it be list. So entire thing came as one variable. Okay. Which is your list. Okay. So this is example of required positional argument, right? Required positional argument. Okay. You have to give A and B and in the same order. I'll create another function called my fun2, right? And here I'm saying A equal to 10 and I'm saying B equal to 20, right? And I'm going to call my fun2. Okay. Now let's print the values here. Okay. So I'm going to say output. Okay. And then I would say output 1, right? And I'm going to copy same stuff and paste it here. And this here, I'm not going to pass any value, right? So obviously, these are default values, right? So default values will be taken into account, right? So you get 3200 and 05. Okay. So this is your default arguments. Okay. How do we perform the third one? Keyword. Keyword, we don't have to make any changes here. Here itself, we have to make change. Okay. So you want to call uh, let's say you want to call fun1 or fun2. Okay, let's call fun1 because fun1 doesn't have default value, right? Fun1, or I can call fun2 also, no problem. And here I'm going to use same variable names. Okay, you have A and B, right? So I'm going to say B equal to and A equal to. Let me give same values. Okay, B, okay, 10, 20, right? So I'm going to give 10, 20 here. But only problem is now B is 10, B is not 20, B is 10, right? So when you run it, you see this will be opposite. Multiplication and addition will remain same. The order doesn't affect multiplication and division, right? 20 plus 10 or 10 plus 20 will be same. But your division is giving you different answer, right? Division A by B is not same as B by A. Until unless both are same, right? So what was 0.5, 10 by 20, not 20 by 10, it give us 2, 2. Okay. So these are your examples of the function that we discussed yesterday. Now there is one more concept here called as variable length arguments. Okay. So I'm going to define, okay, let's say I'm going to pass, let's say, okay. I'm going to say output equal to my fun3. Okay. I'm going to say my fun3. Now in my fun3, okay, first is, let's say, student roll number 100, 1001, let's say. And then you have marks. Okay. Now you don't know how many marks are there. You don't know how many marks. It could be 1 marks, it could be marks in 1 subject, marks in 10 subjects, marks in, any number of subjects. You don't know how many subject are there for marks, right? So what do we do? Okay, we pass all the values. We'll say, okay, function, you handle it. And then there are some attributes of the student. Okay, attribute of the student could be name. This is like keyword, right? So name equal to, let's say, Sachin. Okay, you have sports equal to cricket. You have what, sports, then you have city equal to Mumbai. Now these are some of the attributes that you have, right? And each student might have different attributes. Okay, let's say if you talk about attributes, right? Some may be good at playing sports, so you want to give sports information. Some may be good in studies, so you want to give studies information, like, favorite subject and things like that. Okay, so the parameters that you're passing can also change, and the number of marks that you give can also change, right? So now we can define my fun here. Def my fun3, and here I'm going to say roll number. Okay, so this is roll number is like your required positional argument. First value has to be there, we'll go to roll. Next I'm going to say star marks. Star marks means this is variable length argument. This will read all the numbers that you have. If you don't have any number, it will be blank. If you have 100 numbers, it will read all the 100 numbers as one value. All the 100 numbers will be read as one value. And then you say double star attributes, let's say. Now at double star will read all the keyword arguments. Okay, so single star var will read all your arguments. Okay, double star val will read all your keyword arguments. Okay, so but see, you cannot give 65 names Sachin, 76 sports cricket, 87 cities Mumbai. It cannot read it. Okay, it can read continuous values only. It's not going to pick from the argument. Okay, this is single. Okay, let me take it. Oh, let me take it. No, it is going to read in position, right? Left to right only. So you give all the numbers together and you give all the keywords together. Okay, this you can do it. Okay, I can give this before. So if I give this before, then you have to put this one before, right? But generally, this is how we give. Now you can see the output here. So roll number, okay, and you say comma roll. Then you say print marks obtained, and then you say marks here, right? And you can say print type of marks. right? They'll give you type of marks. Then you say print attributes of student. Okay, you give attribute a ttr. Now you see here, only here I'm giving star and double star, but when I'm using inside, I'm not giving star double star. I'm using the variable name itself. Okay, so you can say print and print here. Okay, you say attribute, paste it here. Okay, and let's run it and see what happens. So see, all the marks have been read from 65 to 78 has been read as tuple. Okay, automatically it reads as tuple, and here it is read as dictionary. So this is how it handle all the attributes. Of course, all the properties that we discussed for tuple and dictionary can be used while working with this. Okay, is it clear? Did you understand this? Respond.
Yes, Swapnil.
Yeah. Okay. So these are different 4 types of functions based on the attribute type. Okay, we are not done yet. We have to do a lot more stuff. Okay. So these are the 4 types. Okay. What I was talking about is okay. Doc string. See, documentation. Every function. Okay, now we have been using print and type, so we know what print typer does, right? So we are not even hesitant of using them. But when you don't know any function, you will be hesitant to use it, right? So it is always good to see what that function do. So we have a concept called docstring. Okay, we have some concept called docstring in Python. So what you can do here, if you want to know what those function does, you simply say print. Actually, help is the function. Okay, help of, you say print. Okay, help of print. So help is a function that will display the documentation string or doc string. We call them as doc string. Okay, we call it as doc string. So doc string will be displayed to us. Okay, so when you run it, you see this is the documentation string. So you can say help of, or you can even say print. So here, see, I'm using the print inbuilt function. So I'm not using bracket here. Okay, while using function only, we'll use print bracket open and close. Okay, now I'm saying print and print dot underscore underscore doc underscore underscore. Now, whenever you see underscore underscore variable, generally 3-letter word will be there. Okay, underscore underscore 3-letter word underscore underscore. That means these variables or functions are predefined. Okay, they have a special meaning. Okay, predefined. Those are not created by us. So you can say doc, and it's going to give us same result. You see, this is what help gave us, and this is what this is also giving us. Okay, prints the values, right? So this is called a doc string. Every function should have, okay, a doc string. How to give doc string to your own function? So doc string, okay, doc string, they are multi-line comments. How to give multi-line comments? Using triple quotation, right? They are multi-line comments added as first line in function definition. So this is a function definition. First multi-line comment. It has to be here. So Python automatically picks. If you have multi-line comment, it will pick. Otherwise, it will say it does not have docstring blank, right? So I'm going to give triple quotation, and it can be any triple quotation, right? You hit enter. So automatically see it has added parameter A, B, and return type. Okay. So this is a sample function to learn about function. This will perform some basic math ops. Okay. Parameter A. This is a number that will take part in math operation, right? What is parameter B? So because as a user, you have to pass the values, right? So you need to know what A and B means, correct? So this is another number that will take part in math op. What is return? It returns a tuple with 3 values, each for addition, multiplication, and division. Okay, so it is must. See, I'm not doing it to save time, but you need to add this must. You need to add docstring for every function that you write. Okay, so if I want to read this, right, I can simply go and here when I go to this one, I will say print. Okay, my function dot docstring underscore underscore doc underscore double underscore. Okay, and when you run it, so see, this is what we wrote, right? This is a sample function to learn about function. This will perform some basic math ops. Parameter A, parameter B, and return. What is return type? Okay, so this is what is called a docstring, and your function should have docstring. So that user who's going to use it for the first time, okay. See, we write programs not to be used by us. We write programs so that others can use it, right? So, so others should know, whoever is using your function, because if I need to know what print does, well, then I can use print. Okay, so this is how you can create docstring. Okay, any questions so far? All good? Okay, now let's say, these functions are done by you, amazing functions, some of the best concept that you have added. I want to use them. I don't want to copy and paste, right? Since you have done it, I will say I want to use it. And this is what module means. Okay, I don't know if we have used any module so far. I think we use random, if I'm not wrong, correct? So what does that random mean? Okay, random is a function which has some, random is a file actually. Okay, not a function. Random is a function, file. Okay, which has some functions. So we might have used random int, random choice. Okay, so those are the functions that perform some activities, but put them together in one file. So if you put these functions together in one file and you call it as p1.py, that means p1 is the module. P1 is module and you gave it to me. And let's say p2 is my file. P1, you gave it to me. So I want to use your functions. So how do I use your function? I will say, I will first copy your file and put it wherever my files are. Okay. So copy and paste there, that location. And I don't need to open it. I don't even have to open your file. I'll simply say import, okay, import, okay, p1. This is how you import a module. Import. And we'll talk about module first, then we'll talk about packages. Okay, so module, okay, import module. Module is a file containing functions. Okay, so you have created all those functions. I want to use them. So I'll say import p1. Now, when I say import p1, all the files are available for us to use. Okay, now I'm going to run it and see. I'm going to run p2 and see what happens. See what happened. So I got all the functions, but whatever work that you have done is also displayed here. Now, if this is your file, I don't want your work to display there. Okay, you have done it. You have written the function here. Great. And these are the work that you have done it, right? And the moment I say import P1, all these things are executed. I don't want to do that. So, okay, again, remember this. Now, see, we are learning new concept every day, and you have to start following those concepts as we learn. So when you write your functions, okay, and these are the work that you have done for yourself. You don't want somebody else program to, it's like without calling only these are getting called, right? And of course, I don't want them. I want to use your function in my own ways, not the way you have done it, right? These are not useful to me. So there's an option here called main. So you say if, okay, if, okay, so I have to check if it is main program or not, right? And if it is main program, only then you want to call them, right? So you have to say if um, uh, if name equal to, you're checking underscore underscore main underscore underscore. Okay, you're checking if the name is main. Okay, if name is main, only then you call these. Otherwise, don't call them. Okay, if name is main. Okay, okay, so name is also underscore underscore. Okay, sorry, that's why it's showing us red here. Underscore underscore equal to main. What does that mean? Every module, okay, when you create a file basically, okay, this is represented as main. So when you run P1 from P1, if you run P1 from P1, the name of this module become main module. Okay, it's like, you don't call your home as your home. You say this is my home, right? You don't say that, you don't refer in third person. When you're home, you say home, right? When you say I'm going home, it means you're going your home only, right? You don't say that I'm going to my home, right? You say that I'm going my home. If you're going to somebody else's home, then you say I'm going to meet so and so, right? But when you're going your home, you just mention it at home. So same thing, when you are calling from your own module, okay, when you're calling from your own module, we call it as main. Module name is main. So name equal to main. So underscore underscore name underscore underscore. Okay, if the name, okay, and when you run, so when you run a file, it sees which file are you running. Okay, you can call multiple files in the same file. Okay, you can call multiple files in the same file. So this name will tell you which file are you calling first. So if you're calling P1 from P1, the name will be main here. Okay, if you're calling P1 from P2, then P2 is main, not P1. Whichever file you're calling, that becomes main. So what I'm saying, if name equal to main, that means if I'm calling this content from P1, then I'm going to put everything, in this if condition. Okay, so if name equal to main, then only perform all this. Otherwise, don't perform this. So now when I call P1, okay, and when I run P1, see all these things are done in the same way, the way we have done it. And that's why, I have been putting all the functions together in the up. Function definition is what you want to share with the other people. If you don't want to share a function, you can put it here in the name main. Whatever you put here is not shared with other people, other files. So functions, I have put it outside because I want to share those functions. But whatever I have done this work, I don't want to share. So I have put this in the name equal to main. So when you call P1, all these are getting called. But now when you go to P2 and call P2, now you see nothing is called. Because whatever we have said, we have put in a condition if. Okay, if you want to see again, I can put else here. Else means when it is not called by, when it is not called by your current program P1, I can say print, thank you for importing my module. So now when you run P1, you don't get this else message. You get all these things. But when you call from P2, see, thank you for importing my module is getting called, right? But obviously we don't write anything in else because we don't want to disturb somebody else's program. Okay. Now I go to P2. When I run P2, nothing is called, right? Now, how do I call your function? So I'll say P1 dot. The moment I say P1 dot, you see all those functions and variables are available, just like we did list dot or dictionary dot, right? You see, V stands for variable. Output 1 was variable. My fun 1, F function. My fun 3, my fun 2. So it tells you it uses AB, it uses AB. Function 3 uses role, marks, and attribute. Okay, so let me call my function 2. And I need to pass value for A and B. See, it's showing A colon int equal to 10. That means it's saying that the first value is A and it is of integer type and it has a default value 10. B is of integer type, has a default value 20. So it tells you all the three. We need all the three. One, A, because if you have to pass keyword, I need to know the original argument name, is it not? If you are passing keyword, we need to know the original argument name. So A, okay, now I can say B equal to 10 and A equal to 20. Okay, so I'm trying to use like a keyword thing. Okay, and I'll say print here. Okay, instead of calling output and okay, let's say we say output out1 equal to, and let's print out here. So see, it gave us output as a list, right? The function is called and output is displayed here, right? I can say my fun 1, okay, same thing, right? I can say 10, 20. If I say 10, 20, then A will take 10, B will take 20, right? So this is how you use module. Module is like using function written by somebody else, okay? And once we are done with functions, we have to do a couple of more topics. We'll do anonymous functions and we have to do recursive function. After that, we'll use a couple of inbuilt module. We'll use random, we'll use date time to handle date time and random. Okay, so this is how you use function. There's one more function called as anonymous function. Okay, last topic for the day. Okay, it's called anonymous function. Now, anonymous function, as the name suggests, is anonymous. Okay, anonymous means it does not have a name. So we call them as anonymous. I don't know the spelling of anonymous, so please pardon me. This should be it. Anonymous function or one-line function. Okay, you cannot use this for everything. Okay, if you can represent your logic in one line, in one expression, then only we use this, because we don't have multiple lines to write. We have only one line to write. So the entire function will be in one line. Okay, so if you have only one line to show, okay, then it is useful, or also called as lambda function, BDA. Lambda, because we use lambda keyword. So anonymous function, one line function, lambda function, they are all same. Okay, how do we write it? So we write lambda colon. Before colon, we give the input parameter. Okay, now input parameter, there is no restriction. You can give any number of arguments as input, right? So let's say I want to perform plus, right? So I'll say x comma y. So x comma y are the input arguments, and this is what I meant that one line. You know, you say x plus y. Now, if you have to add two numbers, you don't have to write a big def and all those things. You can just say lambda input arguments colon and one line expression. This expression cannot be done in multiple lines. So one line expression. Okay. So this does not have a name, right? We have not said def. Okay. This is one line. The expression is one line and you use lambda. That's why, you know, we call them as anonymous or lambda or one line function. Now, if I have to use it, I have to save it somewhere, right? So I'm going to say LF1, lambda function 1. So LF1 is the name I give here. Now, what I'll do, I will say print, okay, LF1, and I'll pass 10, 90. So you see, it gave us 100. So this is useful when you have only one line or one expression, right? You know, for one line, you don't have to write def and, arguments and things like that. This is very efficient if you have only one line of code to write. Okay. So this is how we use lambda function, anonymous function, one line function. Make sense? Then it can get complex also. You can put for loop also in one line, if also in one line, but that's okay. Okay. For now, this is good enough. When we do examples later, we'll see how to implement it with some more examples. But now you know that this is how lambda is used. Okay. So this is a lambda function. There's one more concept in recursion. If you guys give me 5 minutes more, we can finish off that also. Continue or we'll stop here for today? Too much for today.
Yeah, you can continue.
Okay. So thank you. So last concept is recursion. Recursion is like function calling itself. So what we have done so far is we are creating myFun1 and we are calling myFun1. But you can have myFun, say 4, okay, and you define this using myFun1 4, and then somewhere down the line you call myFun4. Okay, now and of course nothing will happen if you call this, but let's say now I'm calling myFun1, myFun4, right? I'm calling myFun4. So what happens? myFun4, okay, so it will call myFun4, myFun4. It goes on, right? It goes on, and after some time it gives up saying, okay, you have reached maximum recursion depth. So if you want to see the output, you can print here, print hello, and you will see the print hello will be called multiple times, right? So it prints. So how does it work? Okay, see, I told you in this case, function is not the first line that is called. Function is called when you invoke it. We call them invoking or calling. So in this file, this is line number 1, line number 2, 3, 4. Okay, this will be called. This is after line number 13, it goes to line number 20. After 13 goes to 20. 20 will call 15, 16, 17. After 17, again it goes to 15, 16. Comes to 17, again it goes there. So it becomes an infinite loop kind of thing. Okay. So there has to be a mechanism to stop it. There has to be a mechanism to stop it. Otherwise, it'll go on forever. So let's say we say here n, okay, and we'll pass, let's say 10. Okay, and when you're calling this, now you're calling with n minus 1, not n, but n minus 1. So it's the same function, but you're calling not with n, you're calling with n minus 1. And what you're doing here is, okay, we're checking. It has to have an ending condition, right? You can't have function calling itself forever, right? Okay, it will not serve any purpose and it'll anyway get into the maximum recursion depth and it'll create problem. So instead what we do is we have a ending condition, stopping condition. So I'm saying if n equal to 0, return 0. Return is when you stop the function. So what happens? 10 is called, 10 it goes here. Okay, let's do with 4. It's easy to explain, right? So when I say myFun4, it goes here, n is 4. Prints hello, is n 0? No, n is not 0. So return is not called. Goes to myFun4 minus n minus 1. So which is now 3. Goes here, hello. 3 is not equal to 0. Comes here, makes it 2, goes up again. 1. So now 2 minus 1, right? 1 is not 0, comes here. Now it is 1 minus 1, 0. Goes up, prints hello. Now it is 0. So returns 0. So it stops here. So you're running into the, into the function. And then there has to one stop. When you reach 0, that's when you say, okay, stop, enough. Don't proceed any further. That's when you come back to your line number 22. So when you run it, okay, you see it's going to print it 5 times. When n is 4, then n is 3, then n is 2, then n is 1, and then n is 0, because you are printing and then checking the value of n, right? If I put hello after this, you'll get only 4 times, right? Sorry. Now you'll get only 4 times, right? So that's the purpose of recursion function. There are some situation where recursion is preferred, okay? When you can, you can you can use recursion logic to perform certain activity, okay? Most common example is factorial. So what is 5 factorial? 5 factorial is 5 into 4 into 3, 5 into 4 into 3 into 2 into 1, correct? Now,
Yes.
you can also say this as 5 factorial equal to 5 into 4 factorial, is it not?
Yeah, it's correct.
Correct? You can say 5, okay, 5 factorial as 5 into 4 factorial, 4 factorial as 4 into 3 factorial, right? So this logic you can implement using recursion. So I'm saying factorial, okay? So my fun factorial, okay? Let me call it my fun factor. Okay, I want to find factorial of 5. So I'm calling my fun factor. So let me call this as my fun factor. So this is 5. When do we stop? When n equal to 0, that's when you return 1. You stop 1. Correct? When n is 0, you stop. Okay. Meanwhile, what you need to do is you call n into, right? So this has to be outside. So what is factorial? Factorial is a return n into my factorial of n minus 1. Got it? So n is n into n minus 1 factorial. Okay, then n minus 1 is n minus 1 into n minus 2 factorial. It goes on till you come n equal to 0 or n equal to 1 also you can stop. Right? Now, if you want to print this, you will get the output here. So this is called recursion, where you see 120 is your actually 5 factorial. So 5 factorial is 5 into n minus 1 factorial. So I'm writing a factorial function, my fun factor, and it has to return n into itself with n minus 1, 5 minus 1. Okay, and you stop when n becomes 0. So it is 1, 1 is returned. So you are able to achieve. Okay, so what happens here? Line number 21 is calling 15. 15 is 5 here. So, okay, it comes here. So it becomes 5 into. Then it goes again with 4. Okay, it becomes 4 into. It goes up again with 3 now. So you say 3 into. Now again it goes up with 2 now. It becomes, okay, into 1, right? 1 into, and it goes up with 0 now. When it is 0, you say return 1. That's when it stopped. So finally, it is calculated from behind. 1 into 1 into 2 into 3 into 4 into 5. It's called, this is generally done using stack implementation. Okay. Stack means last in, first out. So last in was this 1. So this is the first one to come out of this. So 1, then into 1, then into 2, into 3, into 4, into 5. And that's how it became 120. Okay. So again, good to know. And again, you can't use it in every case where there is a opportunity for you to repeat the logic. Okay, that's when this is used. Okay, so with that we finish our functions completely.